In this video, we are looking at angular velocity. The angular velocity is the rate at which an object rotates or revolves around an axis, measuring how fast the angle of an object changes over time. So we know that the formula is W is equal to 2 pi n. But that W is the small lowercase letter for omega. N will be the speed in revs per second, and the W for the omega will be radians per second. So W, omega, is the angular velocity. Explaining that very simply, here we have the formula. So angular velocity, that is the W, equals 2 pi n. The n is in revolutions per second. The W is in radians per second. 2 pi is equivalent to 360 degrees. We also have the formula V is equal to the radius times the angular velocity. So this means the greater the radius, the greater will be the peripheral velocity. Now the V is also known as the circumferential velocity. So the outside velocity, if you look at that circles on the left hand side, let's say that's a tire. So if this is the outer rubber of the tire, and inside that is the rim, the steel rim of the wheel, and this being the valve. The valve will be like the point that's going to rotate in an anti-clockwise direction. So do note that if I increase the radius from the center, what would happen is that the outside peripheral or the circumferential velocity would then be greater. So notice in the diagram we have two different radiuses. So we have a small radius in the center, and we have a larger radius from center all the way to the outside green circle. Notice that the outer green circle will have a higher V than the inner orange circle. So this is where the formula comes in. V is equal to RW. If we increase the radius, we will increase the circumferential velocity. In this video, we are going to speak about that point P, and we will base our thoughts on that point P right there. And so that's what we're going to speak about. So keep these two things in mind as we go through these questions. Right, so the first thing to consider, that's a tire, okay? And we want to convert it from meters into centimeters. That's our first step. So if the radius is 10 meters and we have a certain scale, so if 1 meter equals 1 centimeter, tell me how many centimeters will 10 meters be? Now, I'm not too sure about you, but I have definitely ridden a bicycle, and a bicycle has spokes, like how you see here, spokes. Now I haven't drawn 16 of them, but let's just say there are 16 spokes. I want you to calculate what would be the angle between the spokes if there were 16 of them. Remember that a full rotation has 360 degrees. So keeping in mind that a full rotation has 360 degrees and there are 16 spokes in the wheel, this would mean I'd have to divide it by 16 to know what each sector is. And so this is how I would get a sector. So dividing that by 16, I'll get an answer of 22,5 degrees. Don't forget to press ST, 22,5. Now if A is the center of a circle, this means the two other lines are both radiuses, radii. And if that radii is 10 meters, this would mean I can then calculate the arc length. Now the formula for arc length is S is equal to R times theta. Now S is equal to the arc length. Now that theta is not really in degrees, but it's rather the center angle, which is in radians. Now we did calculate what theta was above. Theta was 22,5 degrees and the radius is 10. Now don't forget to convert from radians, right, degrees to radians. You're going to multiply by pi over 180 because our answer prior to this was in degrees. Now this formula only works with radians. Notice that the blue colored triangle in the center there is radians, but we worked out 22.5 degrees previously. This means I have to take the answer and convert it to radians by saying pi over 180, because this formula S is equal to radius times degrees. Notice that degrees is actually radians and not degrees. So that theta is not degrees, it's degrees times the conversion. Now the answer is 3,93 meters, but the question said work with centimeters. So the first thing we did was convert to centimeters. So our answer will be 3,93 centimeters. Now do note, if you have a protractor, you'll be able to measure the angle between the spokes using a protractor. You can also measure the arc length. How would you do this? By using a flexible ruler or a piece of string and transferring the measurement to the ruler. So arc length can be measured even although it's curving using a piece of string. Indicated by the black ink, the diagram, you would place your string there, take that distance and put on your ruler or use a flexible ruler and get the measurement of the arc length. And then to find the angle between the spokes, you would then place your protractor with the center at A, and then you would measure the angle between the spokes. For example, if those two radiuses here were spokes, then you would just place your protractor at point A and then measure, okay, the angle between those two spokes. And that's how you could do it physically. Now if we were to draw the movement of point P moving in an anti-clockwise direction, we could clearly draw out the shape. So let's say this thing was rotating over a period of 2 minutes. This means after 1 minute it would reach a maximum height. So if it rotates in 2 minutes and makes a full revolution, this means I would start and finish at the same point. Those are the points listed there. After 1 minute it would make half a revolution. So how would my graph look? And so that will be one full rotation. Notice 1 minute, here would be 2 minutes, and here would be 0 minutes. So 0 minutes, 1 minute, 2 minutes. That would be one full rotation after 2 minutes. So now the question says determine the revs per second of this point. That will be the valve on the wheel. Determine in revs per second. So remember, it does a whole revolution in 2 minutes. So 2 minutes is equal to how many seconds? There are 60 seconds in 1 minute. So 2 minutes would be 120 seconds. So to calculate N should be the revs per second. N would be equal to, so 1 revolution in 120 seconds. Our answer would be revolutions per second. So dividing 1 divided by 120, we would get 0,0833. 1 divided by 120, SD, and there's our answer there. Right, it would be nice to use the long answer so that the final answer would be more accurate. Next, we would like to calculate the angular velocity. The angular velocity is what we started off with. W is equal to 2 pi n. Where would we get the n value? We just worked it out above. Punch it into a calculator, the final answer being and the unit will be radians per second. Now something to think about is to calculate the amplitude of the wave. What is the amplitude from the lowest spot to the highest spot, okay, of the graph? And take that and divide it by 2. And so this means I'd have to know what the top number is and what the bottom number is. Let's say the top number. Now let's say we wanted to find the equation of this graph. So that means this graph is a negative cos graph. It would have an amplitude in front of cos, followed by angular velocity times time, and q would be the shift. So now we'd need to find those parameters. So we did work out what was the angular velocity. Our angular velocity was a full rotation, which is 2 pi divided by 120 seconds. So that's equivalent to pi over 60. Now a is the amplitude. To find the amplitude, we'd have to take our two extreme points, subtract them up, and divide it by 2, and this would give us our amplitude. 20 divided by 2 is 10. Next we want to find, and to find the shift, it'll be 26 plus 6 divided by 2, and that will give us, and so now we have 16. We know that W is equal to pi over 60, and tell me how much is our time. Now notice here, time must be in seconds because why? Angular velocity is in radians per seconds. But we have the time in minutes, and it is 1 minute. So 1 minute is equal to 60 seconds. Let's start substituting into the formula. So A is going to be 10. The angular velocity is pi over 60. Our time has to be 60 seconds. And our Q is 16. Punch all that into the calculator. So notice you can punch it in as cos pi equals times minus 10. And that's what you get, minus 9,984. Make it 985. Add 16 to it. And so after 1 minute, the maximum height, right, would be 6 meters. Okay, and that's how we would solve for that.